Today in the AWS Developers Podcast, we're talking about a migration from an ASP.NET monolithic SQL Server application to the cloud, serverless, and we explain all that. It's with Moonpig. Good morning, good afternoon. Thank you for downloading the AWS Developers Podcast. We are available in all your good podcast applications, Spotify, YouTube, Deezer, Apple Podcast, and many others. Please leave us your feedback and your comments every week. We dive into an AWS architecture or service or return on experience. This time with Moonpig, with not only a single guest, but two guests. Richard Pearson, your head of engineering, and Alexis Lowe, your principal engineer at Moonpig. Thank you for being here. And as usual, I'm starting with a very open and very broad and very naive questions. What is Moonpig?
We sell gifts, cards, flowers, anything you might want to make somebody's day special. We've been in existence for 25 years. We started in the UK, but we span over a number of territories now with our Greets brand in the Netherlands. And then for our Moonpig brand, we actually sell across the UK markets, US markets, Australia.
So as a customer, I go to moonpig.co.uk and I can browse your catalogs. Moonpig.com.
For any UK listeners, there's a very well-known jingle that comes, which I am not singing, which comes along with moonpig.com. But that's our main website.
So you're in the e-commerce world, a world that we know quite well at Amazon as well. And you had a quite interesting journey to the cloud, because as I said very quickly in the introduction, you start with a monolithic ASP.NET mono database. So what was your infrastructure at the start, and towards what did you migrate? I know we can probably talk for the rest of the podcast with just that question, but we are going to break down into different parts. But what was your starting point?
At the very start, it was on-premise virtualization platform. I believe it was VMware. Mm-hmm. And it was running ISS and ASP.NET workloads to host a website. And it did have a API that was used by the first app, which I believe is the Android app. And then all the data was centralized in a Microsoft SQL database, which hosted everything. So all the tables existed on the one server.
When are we talking about, just to put that in context of time?
I want to say that they started the project, because I wasn't there when they started it. That was probably it from the very, very beginning. So probably like
10 years ago.
Richard said, over 20 years ago when they started.
Yeah. Mm-hmm. And at the time it was UK only, it was not global?
At the time it was UK only, though when we started the migration project, we already started talking about Australia and the US. So
what are the typical pain points you had with the on-premise monolithic architecture? I know you were both not there at the beginning, but what triggered that project to migrate to the cloud?
It's probably mostly scaling and reliability. So the website was seeing more and more customers, and it was struggling to keep up to scale, especially with our peaks. So as a gifting business, we've got specific days that are very high traffic. So things like Christmas, Valentine's Day, Mother's Day. And during those periods of time, the workload on the systems is more than 10x. So they were struggling to keep those things scaled up, and that was part of the reason to move.
And there was a very specific architecture choice to go to serverless. So it was not only moving to the cloud like most companies are doing. They take whatever they have and they lift and shift. You decide to rewrite.
It started as a lift and shift.
Okay, that makes sense. That's what companies are doing.
So the very first thing they did was a plain lift and shift. It did help with stabilizing and scaling because you can just pick more EC2 instances and add more systems. But it very much started there. Later on, serverless was picked as the final solution when we decided to completely replatform the system, and again chasing more scaling because our workloads are very, very spiky.
So the idea was most companies are doing the same. So they first lift and shift, learn how to automate the clouds, how to put alerts, how to manage cost, and then at a later stage they decide to re-architect. And as you mentioned, re-architecture there was mostly for more scalability. What was the architecture decision that you took at the time?
So we moved to serverless for a few reasons. More scalability is one of them. The other is we wanted to remove the mental load of having to build your own infrastructure and manage your own infrastructure. With EC2 instances, you need to think about networking. You need to think about how much CPU, how much RAM you're giving to your workloads. Whereas with serverless, you just put your workload on there and it will scale automatically for you. The other thing was we wanted to scale the number of teams we had and the amount of feature work we were doing. And that led to us making sure that our teams don't need to worry about all the other things, and we make their developer experience simpler.
So when you say serverless, you mentioned Lambda, that's the compute. I guess you have like a multi-tier architecture with a front-end, back-end microservice, or API at least, and then a database. What is the technical stack you operate today?
So it's for compute or Lambda. There is no Fargates or EC2s. And then what we have is CloudFront pointing to API gateway, and then your Lambdas behind it. And then the backends and the front ends are again hosted on Lambda, the backend being a GraphQL gateway, so Apollo GraphQL gateway. No, running on Lambda.
Running on Lambda, okay.
Yeah. And then the website is a Next.js app, also directly hosted on Lambda. But the conversion code at the time of when we started the new platform was all in-house. And now it's just AWS Lambda with a web adapter layer on it.
The web adapter for listeners, it's like it's an extension of Lambda, so it's a process running inside the Lambda that will take whatever is coming from the API gateway and transform that in a real HTTP request so that you can host your Next.js app unmodified on Lambda. Am I correct?
Yeah, that's exactly it. We used to have all of that code running, so we would invoke Next.js manually using some tricks that they used to make available. And then in the latest versions of Next.js, they got rid of the concept of serverless, and we've had to change and swap to the web adapter.
And then for the database, serverless means Aurora or DynamoDB?
So we have a preference for DynamoDB across the entire estate. We don't really like SQL, but where we have relational databases, like when we have relational data and it really needs a that SQL database, we leverage Aurora Serverless v2. So we really try and not own any kind of database if possible. That
triggers a ton of questions on my side. I guess you didn't interrupt the website and the service during the migration. How to migrate the data from a SQL Server relational database to DynamoDB on the flow while keeping things moving?
Yeah, so that was done by basically hosting the old website as well as the new website at the same time, and then migrating things to the new APIs that talk to their own databases. and then using events to write back to the old database. So when you migrated a new service, so I'll take the purchasing, for example. When that was migrated, it had a write back into the original database, but also wrote to its new databases, and meant that we had this write back, but also for the front end, what we did is we had a CloudFront. I believe it was a Lambda Edge that did the path rewriting. So when the customer was going to let's say checkout /checkout, they would automatically be pushed to the new stack, but the rest of their journey would have been on the old stack. And then as we moved domains across, we would change the sort of like that front gateway to point to new places.
This is a pattern that is called the strangler fig pattern, if I'm correct. So you're removing functions from the monolith, one by one, by redirecting the user to the new stack until there is nothing left in the old stack. We're talking about how many services, how many functions or groups of functions, roughly. I'm not expecting the exact number, in the dozens, I guess.
So today, in terms of backends or domains we have, there's 26 domains.
Oh.
So the way we know that is we use Apollo Federation for GraphQL. And so we have 26 subgraphs, which are mapped to our domains. So there's supposedly 26 domains there. I don't know what it looked like before the new platform, but that's what we've ended up with now.
You have an idea how long it took to denature the old platform to apply this strangler fig pattern? Are we talking in weeks, in months? Or?
It was years. It was a couple of years to do the entire end-to-end journey from starting. Wow. So I remember I joined a few years back, and it was still undergoing towards the end of the project. But it's like most things, you can get the 90% very quickly, but your last 10% takes much longer to figure out, especially when you're talking about legacy architecture, where you're like, okay, something's calling this URL, but I don't know what it is that's calling this URL. So you spend an awful lot of time tracking those things down. So yeah, I think the last 10% probably took quite a chunk of time compared to the first 90%.
But you eventually get rid of it?
We eventually
is it shut down now?
Yeah. So yeah, so that central SQL database is gone. Which was a nice day when that finally.
I guess that you celebrate.
Absolutely.
Well, one of the things that was really interesting is towards the end of this migration to the new platform, we acquired Greets, and we wanted to take the Greets brand and put it on the new platform. So we redeployed the entire new platform because we run both brands. We basically run everything from the same code but configured differently. So you'll find a Lambda running the Moonpig code and a Lambda running the Greets code. But both Lambdas run the same exact code. It's just they have slightly different configuration to make sure that the brandings are different. And when we finished the Greets work of migrating them to the new platform is when we went, wait a second, this is running without touching the old world. So we must be able to run Moonpig without touching the old world at all. And so that was sort of like the real like light bulb moment of like, oh, this is actually dead now. We can really go and kill
turn it off.
Yeah.
I guess you put in place tons of monitoring as well to monitor the traffic on the old platform to be sure that the thing was left there. That's the power of IIC, of infrastructure as code, where you can deploy the same stack over and over again and run different platforms or different virtual shops from the same code base in different infrastructure. During that period, you went multi-regions as well to expand your business overseas. Mm-hmm. What were the specific challenge to address the multi-region deployment?
It's difficult to call it a challenge because I've always seen it. It's like I've sort of always lived on the solve side of it. The magic trick, and it applies to the multi-brand thing, is we treat each region as an entire deployment itself. So from an ISE perspective, you're deploying to every region as if it was an entire like separate environment. But then we have replication of data with like DynamoDB replicated tables or those kind of things. So what you end up with is this multi-region active system because the entire US East stack is the same as the entire EU West stack. There's no difference. There's the same code. It's the same data. They both receive events, the same events. So all the tables have the same amount of like the same type of information, etc. There might be eventual consistency problems between the two regions. So if you found yourself hopping between them, you might see something weird. But the way we do the region mapping is based on geo-based routing, so it's less about resilient, like letting the customer hop between it and resiliency between the two regions, and more about making sure our customers in Australia don't have any bad latency, or our customers in the US don't have any bad latency. So when you're making a request, Route 53 does the geo-based routing to the correct place. CloudFront then does the same thing with its origins, and then it calls to another, like the backend Route 53, which also does geo-based routing. So the whole way through, you're being directed to the region that is closest to you, and you end up with the data that matters to you because you're always sort of talking to the same region. If you did swap, or if we did kill off one of the regions, most customers wouldn't notice because eventually the events between them will balance out the data.
And it's very unlikely that a customer jumps in between regions unless you're playing with VPN very, very aggressively. But if you follow a customer request through from the customer browser to the data, I am in the US, I make a request to moonpig.com, the DNS will point me to the closest CloudFront distribution, which in turn will point me to the closest API gateway and Lambda, so which is probably in US East or somewhere in one of the US region. And from there, the configuration tells the Lambda to address the database, which is there too, so there is no cross-region traffic. But every time data is written in Dynamo will replicate the data to the other. So it's a global a collection of DynamoDB global tables.
Yeah, the tables tend to be global tables, but in some cases we decided to have just the one table because what's happening is that table, like for example, maybe the API doesn't have any writes to it, but the table is purely read and receives events. So like, let's say a product table, for example, that product table will have a list of all the products and all the descriptions and etc. But where that's coming from is actually events. So we use event-driven sourcing for the data. And that might come from, those events could be fired from any region. All the regions are listening to all the events, and then they will write to their DynamoDBs. And so we avoid writing twice to the same table by doing that. And it also means that we save on replication and whatnot.
Yeah. It increases a bit of latency, but it has the advantage.
There's latency on the eventual consistency, but
for the eventual. But as I said, it's very unlikely that a customer take a very quick plane and move to another region and continue the session from another region. I guess you're doing that for testing sometimes with VPN and seeing how it works.
Yeah.
And if one region unfortunately becomes unavailable, or if your infrastructure has a problem in one of the region, it's the Route 53 health checks that will redirect the traffic to another region.
Yeah, exactly. So all the Route 53 geo-based routing also does the health checks on the region that it's routing you to. So if that region's down, it'll point you to the next one.
And currently you're operating globally in 3 geographies: North America, Europe, and Australia?
Yeah, that's correct.
Wow. And but all the data are shared. So if I'm a customer, I have the same username, password, wherever I'm routed.
Yes. So the website has a concept of stores, but that's purely from a fulfillment perspective. So how the when you're buying something, if you want to buy something for an American person, or if you're buying something in America, you probably want to go to the American store on the website. From a technological,
the inventory and the availability of items in that market.
But from a technological point of view, it doesn't matter if you do that from the US or from Australia or from the UK.
What are you using for user authentication? I'm asking the question because if you go serverless on AWS, it's probably Cognito, but I know Cognito as of today is not multi-regional, so you might have challenges over there.
We use a third party for our authentication. They do all the hosting for us, and we just send the calls to them. But we use Lambda authorizers for all the checking of the tokens.
So a Lambda authorizer for our listeners, it's a Lambda function called by the API gateway to validate the calls coming through the API gateway, where you run your custom code. Basically, you receive the HTTP headers, you run your custom validation logic, and then you let your customer work through it. It's funny that you mentioned that because I was working on Lambda authorizer no later than yesterday. What are the main benefits that you're observing? You applied the new architecture for scalability and resiliency. How does that reflect in numbers? If you can share any numbers, don't disclose anything that you can't.
I think probably the best thing to say, although I'm not going to give you numbers, I'm going to give you a scenario, and that scenario is unfortunately COVID. Now, when COVID hit, we were in a situation where everyone couldn't go out to the shops and buy cards. So from a business perspective, that was, we suddenly found a lot more people were suddenly buying cards online. And I think it's interesting to sort of, I don't know, Alexis, if you remember how much traffic sort of increased over COVID times, but it was considerable. And if we hadn't been on this new platform at that point, or the start, at least I think in 2020, we were at least partway through the replatforming journey, if not fully through it. If we hadn't been in that position, we would have had so many more scaling problems on a day-to-day. So just being able to take that uplift of that traffic has definitely paid off in terms of the investment. Alexis, I don't know if you're going to add something there.
Yeah, we went from without giving any numbers, we went from like what we would see in a week in a day in terms of traffic. So it was quite a lot. Wow. But one of the really interesting things with everything being extremely everything we make serverless. What was really interesting is the traffic is extremely peaky. So when I say I talk about peaks, I mean throughout the week it's really peaky. So like a Monday might be more busy than a Tuesday, but also throughout the day itself, it's basically a bell curve in terms of like you're talking about people at lunchtime looking at their phones and buying cards versus and late at night you don't really see any customers buying unless they're maybe in Australia, and this peaky traffic directly correlates with how much it costs to serve that user, because of how serverless we are. So the traffic pattern maps to the AWS bill pattern, if that makes sense, and that's really powerful because it means when we did Greets, for example, we onboarded this entire new brand, but it cost exactly the same to run that brand as it does to cost Moonpig if you gave them the same amount of customers visiting. And that's something that like I've never seen. Like normally there's like a cost of like how many servers I need to buy, and they normally very wild and very different between the brands or between the companies that you're trying to serve. But in this case, they're exactly the same. The cost per order is the same. There's no difference there. The other thing that's really cool from a technical point of view, and this always makes me happy, is I can explain to Richard that I'm going to go and do some optimization work. Like I can go and spend hours on O of X problems and etc. in my code, and I can't be told, oh, that's not worth it, because when I finish that piece of work, I normally bring down the AWS bill, because my Lambda's running for less time, or because my number of calls to the DynamoDB has gone down, and etc. And that immediately translates into a better experience for the customer because they're seeing lower latency, but also an immediate effect on our AWS bill.
That's the huge advantage of serverless architecture, when you can really correlate and map the cost to the business value. More traffic means more cost, but if you have more traffic, you have more purchases as well. And every single millisecond matter, because Lambda compute is built by the millisecond. So if you can achieve like 10 millisecond improvement on one specific function multiplied by the traffic that you have, that's direct a correlation of your build as well. You told me something quite strong when we were preparing this conversation, is that VPCs are not allowed.
Yep.
It's full serverless. No database running in a network, no network to manage.
It's full serverless until AWS makes you deploy a VPC, because their serverless offering requires a VPC. So we only have the default VPCs that come with AWS accounts. We don't tend to create VPCs beyond that. The reasoning behind this is a VPC has a certain amount of overhead. It requires networking. It requires figuring out the security groups. It requires figuring out IP addresses. And a lot of that stuff within Moonpig is managed by IT department, which isn't an engineering function. So if you need a static IP address for your service, then you're having to talk to an entire different department to get the IP addresses and etc. And it's really slow. It's really clunky. It's very it doesn't feel agile in many ways. But so we've made this decision that if you're building a VPC, you're probably doing something wrong. Obviously, with some of the services that are serverless, you have to have a VPC. So for example, Aura Serverless V2 for some reason makes you create a VPC. I imagine it's for connectivity reasons, but that's like we build it, we give it the default
because you're obliged to.
Yeah, we give it the defaults and we leave it there, and that's how we sort of go with those. Same for I think it's DAX and so DynamoDB DAX, the thing that lets you call your DynamoDB even faster.
The accelerator, yeah.
Yeah, the accelerator, I think that requires a VPC. So when we're dealing with those scenarios, we'll obviously weigh the pros and cons and accept the VPC, but majority of Moonpig stack doesn't see a VPC, doesn't see an EC2 instance, doesn't see ECS, and anything that has the E in it, in EBS volume is alien to Moonpig people.
When I hear you talking, I have the impression you also move to a full DevOps type of organization where the developer is responsible for the code into production as well. So let's talk a bit more about that. What are the organizational changes that were introduced by this new architecture? Did you went from traditional development versus production department now merge into DevOps?
Yeah, so again, I think the main sort of fundamental changes were slightly before mine and Alexis's time. But I think prior to the organization that you described there, of effectively having those sort of operations team who look after infrastructure, was definitely how things were. I think when I joined, which is slightly into the transition, we had formed what were called tech foundations teams. And the idea was that those teams would be responsible for effectively the underlying foundations, be it the IAC standards, be it some of the developer tooling, the observability, logging type stacks. And then over time, we've evolved them into what we called enablement functions. So today we have a platform team which has two purposes. We have an infrastructure platform team who look after effectively everything to do with AWS accounts, IAM policies, various other things. And then we have a web platform who deal more with how we have a web platform team who deal more with how the website, the actual sort of web application is usable by teams. And then we have a developer experience team who look after observability, logging, design systems, those type of things. So we pivoted this to effectively the teams own the code they deploy, but we put teams in place to enable them to do so in the most efficient way. So effectively, you shouldn't be in a situation where, CI/CD is not working. We need Bob from team B over there to come fix it because he's the only one in the organization that knows it. We're in a situation where, no, CI/CD is owned by the developer experience team. But at the same time, they're not there to gatekeep. They're not the people who do the work. They're not the people who a team comes to going, we need a CI/CD pipeline. Can you do it for us? That is not their role. Their role is to go, this is how you create CI/CD pipelines. And the teams go, thanks, great. We can adopt that and we can use that within our teams.
So it's a matter of defining the guardrails, the best practice for architecture, for security, and to ensure that all the teams are repeating that. Maybe through code and infrastructure as code as well. You might have CI/CD as an ISC, as an infrastructure as code component that teams can deploy inside their environment.
Yeah. Every team follows CI/CD, and we use Terraform now, OpenTofu to manage all the code. But we've, like Richard was saying, we've standardized nearly everything. We've created modules for all of the scenarios we saw people building. So, for example, a majority of our teams are building a Lambda with listening to an SNS that feeds into an SQS that then outputs to another SQS, and that pattern there is a module that they can just pull and give it a name and they're done. So we've standardized a lot of how they do their Terraform, how they deploy their code, and hopefully bring it to they only need to think about the code that's running in the Lambda rather than all the rest of the Terraform that they have. So that's sort of like what we've done with these enablement teams, is try and remove the need for a large ops operation to ops team to run their code.
Richard, you mentioned it, observability. Typically, when talking with customer moving to serverless, that's one of the big challenges, to understand how to trace a request from end to end through Event Bridge, through API Gateway, multiple Lambda, and things like that. Was it a challenge for you as well? How did you address that? What are the tools you're using? How observability is working at Moonpig?
So yeah, I think it's an interesting one, because although obviously we've spoken about where we are in our journey, I think tracing is always a very difficult problem to solve. So I think even we still have a journey to do in terms of getting full end-to-end visibility on tracing, but we are sort of on that journey now. In terms of where we are and where we have been, we have effectively, we utilize OpenSearch as our main logging cluster. So everything from CloudWatch logs are shipped to a central OpenSearch cluster, which then has your standard OpenSearch dashboard, or I have to go what it's called. It used to be Elk, didn't it? But whatever it's called these days. And so, yeah, that is our main sort of central point for being able to effectively query logs across the estate. Similarly, we utilize CloudWatch metrics and then expose those into Grafana dashboards. And then we utilize CloudWatch alarms across the estate, which is our main sort of source of things going wrong. And then we aggregate those into, other alerting platforms that call out of hours people, or however it might be.
Yeah, send the SMS or call the person.
Oh yeah, everything that you get from one of those type of products.
What did you learn during this journey between the original vision of going serverless and replacing a monolith by microservices to actually where you are today and what you have in mind for the future? What are the lessons learned? If you have a new customer, AWS customer willing to start the same type of migration, what would be your wise advice?
I think for me, the main thing is to, and this is more of an observation that I've seen outside of Moonpig, so having been at other businesses, is commit to the migration. Because it's very hard, it's very easy to get to that 90% as we talked about, but that last 10% of your migration is the hardest part. And if you go, oh, well, it's not worth doing this last 10%, you end up in a position where you're suddenly running two platforms with little bits of leftover things and mostly shiny. So I think for me, if you're thinking of starting a migration journey, you have to effectively be in a position where you go, okay, we're doing this and we're committing to the end, and that we make sure that we have clear business buy-in to complete this journey.
Mm-hmm.
I think we've completed that well at Moonpig.
Alexis?
I think for me personally, it's the don't fear serverless, don't fear the vendor lock-in, don't fear all of those things. It's worth doing. If you really think about it, you're going to have to rewrite it in any case when you move to another vendor, even if you did have something that was super agnostic. So yeah, really embrace it, because embracing it has meant that we've managed to achieve where we're at now, which back when we started, there was definitely some pushback from people about like the idea of serverless. What about cold starts? What about all these things? And we solved around those by not embracing it. So for example, for cold starts, we would make sure there's always something hitting a lambda, so that the lambda is always there, and or over provision it and etc. But we've now reached a point where it's like, actually, what's the point of that? Why are we spending money for this? We can accept the cold start and make sure that the user interface has maybe a spinning wheel when that happens, but we give the user an experience that is where they don't notice that things are loading and etc. And really embracing it means that you then get all the benefits of it. And yeah, it's been great from that point of view.
That's a fascinating story, migrating from a monolith first with a lift and shift and then a refactor in serverless, and the decision why to move to serverless and to avoid VPC at all costs unless AWS obliges you to have one, but also adopt infrastructure as code, CI/CD practice. Thank you, gentlemen. Richard Pearson, your head of engineering, and Alexis Lowe, principal engineer both at Moonpig. So next time you go to moonpig.com, you will have a glimpse of what's happening behind the scenes about with your query with Route 53, API Gateway, Lambda, DynamoDB, replication across 3 continents. Thank you for sharing a bit of your journey and your experience about that migration. Thank you for having listened to this episode until the end. Next episode is next Friday in all good podcast application, but now go build.